So when we have a rational equation or equations with fractions, basically we want to get rid of the divide. And we can get rid of divide by multiplication. So if I have a quarter of an x, so that circle represents a whole x, and that balance is 5. If I make it 4 times bigger, I can have a whole x here. As long as I make the other side 4 times bigger, it will remain balanced. So I get x equals 20. So the idea that as long as we keep it balanced, okay, we can do whatever we want. In this case, I don't want to mess with that fraction, so I can get rid of that divide 2 with a times 2. Okay, so I'm going to just get rid of that divide 2. I'm going to make everything 2 times bigger. And in doing that, we end up with 1 whole x, 10, and 24. Okay, and then we can solve for the x by taking away 10. We get x equals 14. And we can see that it works by plugging it back in. Well, half an x is 7, plus 5 balances 12. That's perfectly correct. So, system of equations. System of equations is when we have two variables and two equations. Okay, if we have two relationships and two variables, it is a system that can be solved. Now the goal is we want to eliminate one of the variables and then we can solve for the other variable. So we can eliminate the variable by two strategies, substitution or addition subtraction. So here I'm going to do a substitution because I can see that this y, the y is same as negative 3x plus 8, and I can say that through negative 3x plus 8 can replace that y, or we could do it the other way around. But I'm just going to do it that way. I'm going to go say 3x plus 2 is equal to, and as long as I replace this y with something equivalent, I can keep it balanced. And remember, that's the only rule of equations. I just need to make sure I keep it balanced. So if I replace the y with a negative 3x plus 8, this remains balanced. Now I only have one variable to solve for, which I can solve. So I'm going to do plus 3. Remember that these do not cancel. So I get plus 3x plus 3x. I'm going to take away 2 from both sides. So I end up with 6x on this side, and this is balancing 6 ones. Divide by 2, I get x equals 1. Okay, so I haven't solved this yet because I actually have to solve for the other variable. Remember that there's two variables involved, so I need a solution for x and y. Now to solve for y, I'm just going to plug it back into this original equation. Y is equal to negative 3x plus 8. Well, I found out x was 1, so when I plug it in, I get y is equal to 5. There's my solution. And I can check this by plugging it in. So 3 times 1, that's 3 times 1 is equal to 3, plus 2 is equal to y is 5. That's correct. Here I can say y is equal to 5, so negative 3 times 1 is negative 3, plus 8 is 5. So 5 equals 5, so that is correct. Okay, so we can also check this by graphing this as well. Okay, we can actually sketch a graph of this. So 3x plus 2 looks something like that. Negative 3x plus 8 looks like something like that. And we end up with a solution at x equals 1 and y equals 5. Okay, so that's what the solution would look like on a graph. The other way to solve a system is by addition subtraction. So if I have these two equations, I'm going to call this equation 1, this equation 2. I can put equation 2 underneath here like this. And I can just combine these by adding these together. And again, the only rule is balanced. If this is balanced and this is balanced, if I combine two balances together, it stays balanced. So when I add these together, I get 9x, and notice what happens to the y's. Our y's cancel out. Since our y's cancel out, now we can solve for x. 9x equals negative 6. Divide both sides by 9. I get negative 6 over 9. That becomes negative 2/3. There's my solution for x. So how do I solve for y? Well, I plug it back into one of the equations. So if I plug the x back into here, I end up with this equation. I end up with 3x plus 2y minus 4 equals 0. And notice that the only variable left in this equation is y, which is the one I want to solve for. So I go ahead and solve for y. This becomes negative 2 times 3 divided by 3. Well, 3 times 3 divide 3 cancel out. Okay, so I end up with 2y minus 6 equals 0. 2y equals 6. Divide by 2, divide by 2. Y is equal to 3. Okay, and if I plug it in, negative 2/3, I'll plug it into this one, negative 2/3 times 6 is going to be negative 12. Negative 4 minus 2 times 3 is 6. So negative 4 minus 6 is negative 10, plus 10 equals 0. That's perfectly fine. Okay, so I want you to take these same equations and I want you to plug them into a graphing tool, okay, and solve those systems by graphing. Okay, so you can use that link. You can use Desmos too to do it, but I want you to solve some systems by graphing.